Okay, this is part 2 of 8.02 on balancing equations. And what we're going to do here is let's flip back to the last page to 801. And let's go to those two equations that we did, where we did sodium oxide plus water gives us sodium hydroxide, and zinc oxide plus carbon gives us zinc plus carbon dioxide. So I'd like you to pause the video. To start off with, let's do a little bit of practice. Go ahead and try to balance these and see how you do. All right, let's check your work. Welcome back. So as we look at sodium oxide plus water, if you wanted to do an element, sodium, I've got hydrogen and I've got oxygen, and then over here I've got sodium, hydrogen, and oxygen. 2 sodium here, 1 here. I've got 2 hydrogen. I've got 1 hydrogen, and here I've got oxygen shows up twice. So here I have 2 oxygen. So we want to save hydrogen and oxygen for last. That gives us sodium. So if I've got 2 sodium here, I'm going to put a 2 here. That's going to change this to 2. And that's going to change this to 2, and that's going to change that to 2. So that actually takes care of everything for us, putting a 2 in front of the sodium hydroxide. Down here for my zinc oxide and my carbon, this one I've got zinc, I've got oxygen, I've got carbon, I've got 1, 1, and 1. And over here I've got zinc, carbon, and oxygen, and I've got 1, 1, and 2. So I need a little more oxygen on this side. So I'm going to put a 2 over here to balance the oxygens. Well, that makes my zinc unbalanced because now I have 2 zinc over here. So I'm going to put a 2 here. And remember, when there's no coefficient, it's implied that there's a 1. So even though I don't have a number there, 1 is implied. Okay, let's go back to those word equations into chemical equations. We've got 2. Now I'm going to start off and I'm going to show you the wrong way. Let's put this in red because this is going to be, let's put it in orange. This is going to be wrong. Oh, I lied. Light blue. So right off the bat, I'm going to tell you I'm doing this the wrong way. So I start to read this and I write my equation as I go. And this is what students do, even if they don't do it on a regular basis, at least part of the time. So they say copper 1 chloride. Okay, that's going to be CuCl. And I'm going to add to that zinc. And that's going to make copper 1 sulfide. So that's going to be CuS plus zinc chloride is going to be ZnCl. And everything's balanced and everything's good. Can you see where my mistake was? Maybe you see it right away. Maybe you don't. Let's go through the correct way, and then we'll go back up to this wrong way and show you what went wrong. You have to write, so I'm going to make this guideline number 5. This should have been number 1, but it will get on the list. You must have correct formulas. If you don't have correct formulas, you're wrong right off the bat. All right, let's go through and write our formulas before we make our equation. So copper 1 means I have copper plus 1 and chloride is Cl minus 1. Zinc by itself is just going to be Zn. Copper 1 sulfide, I'm going to have zinc sulfide. My goodness, that was a mistake. That should be Zn plus 2. Sulfide is S minus 2. So I have the same anions and cations, they're just mixed up. So I have copper plus 1, sulfides minus 2. I have zinc plus 2, and chloride is minus 1. So when I write these formulas, I have copper 1 chloride is going to be CuCl. That was correct. Zinc sulfide is going to be ZnS, and that's correct. But look what happens. If I put 1 copper plus 1 with sulfide, that's not going to equal 0. That's an incorrect formula. The formula here has to be Cu2S. And similarly, zinc is +2, chloride's -1, so I have to have ZnCl2. So when I write this out, I'm going to have Cu2S plus ZnCl2. Make a little space here. This is the correct equation. Over here, you wrote on the right side, you wrote compounds that wouldn't exist. So because you just wrote, you were balancing, as I was doing this, I was balancing as I was writing. I call this balancing while writing. And that'll always give you incorrect formulas. Copper 1 sulfide is Cu2S, always. If you wrote CuS, this is a non-existent compound. Now I can balance this. So go ahead, pause the video, see if you can get it balanced. All right, did you see that all you needed to do was to add a 2 here? Because I have one zinc, I've got one sulfide, but I've got 2 copper and 2 chlorides. If I put a 2 here, that will balance for me. All right, why don't you go ahead and do the next one as practice? So pause the video and try to do this one, and we'll check you on the other side. Okay, so we've got sodium plus chlorine gas yields sodium chloride. Let's go with right here. Sodium by itself is just going to be Na. Chlorine gas, this indicates that it's elemental. So this is going to be Cl, but remember when hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are by themselves, they're diatomic. Something we've been talking about for a long time. Sodium is, now we have an ionic compound. So I have an element, and this is going to be an ionic compound. How did I know that? It's by itself. Anytime a substance is by itself, that indicates that it's a compound. Over here, though, sodium chloride, sodium's +1, chloride's -1, so that's going to be NaCl. So when I go to balance, I have 2 chlorine here, and I've only got 1 on this side. You'll notice I'm not doing my banks. As you get faster at this, you can drop that, but that gives me 2 sodium. So I need a 2 there, and there's an applied 1 there. All right, let's see. I think probably enough practice for today, and that wraps up the second half of this. Let's do our takeaways. So we've got some guidelines. When you are balancing equations, change the coefficients, never the formulas. And this really should have been number 1, make sure your formulas are correct. Group your polyatomics together. So instead of writing out SO4, if you've got like down here, you'll notice, well, I didn't have hydroxides on both sides, but if you have polyatomics on both sides, keep those together. Balance a substance that only appears once on each side of the equation, and that's usually not hydrogen or oxygen, so save those for last. So at this point, you'll be heading into the homework and be doing some practice problems, and that's it for balancing to satisfy the law of conservation of matter.